again, everyone. Welcome to another edition of Weather or Not. I'm your host, Chief Meteorologist Jerry Jackson of Storm Team 9. One of my primary jobs is to track dangerous weather and give you adequate time to prepare. For longer-term events like snowstorms or hurricanes, that requires some planning on your part, too.
Hurricane Helene made landfall in the Big Bend region of Florida. With a forward speed of over 20 miles per hour, it quickly progressed into Georgia and then over the southern Appalachian Mountains on September 27th before gradually dissipating to the northwest by September 29th. The storm brought record-breaking rainfall to portions of the area, which was worsened by a prior rainfall on September 26th. Historic flooding and devastation occurred along portions of the far eastern Tennessee mountains, with even more widespread impacts to the east. In addition to the rainfall, the storm brought 40 to 60 mile per hour winds, which led to extensive and long-lasting power outages. Hurricane Helene is the third deadliest hurricane of the modern era behind Maria and Katrina. Catastrophic flooding requires a combination of flooding that is exceptionally heavy and exceptionally long-lasting. As Helene interacted with an anomalous closed low over the mid-Mississippi Valley, moisture feeding towards a stalled cold front across southwest Virginia and East Tennessee allowed a remarkably persistent predecessor rain event. As Helene was unusually large, intense, and fast-moving, the prolific rain of the storm's extratropical core was able to follow the prior rain event with extreme short duration of rain that increased the flash flooding potential. This all happened atop the southern Appalachian Mountains, some of the most complex topography in the eastern United States. Rain intensity was tropical in nature, and the heavy rainfall was contributed by the topographical orographic lift. Both the hurricane and the upper low were responsible for the extreme rainfall that occurred over North Carolina, since either one of themselves would not have resulted in such an extreme event. The storm brought catastrophic inland flooding, extreme winds, deadly storm surge, and numerous tornadoes that devastated portions of southeastern United States and the southern Appalachian Mountains.
When heavy precipitation becomes an issue, sometimes it's just best to postpone travel and spend a little relaxation time at home. A calming board game goes a long way towards resetting your nerves, and board games come in all shapes, sizes, and themes. Here's one I think you'll like. Burger Academy is a game published by Playroom Games. Takes about a half hour to play and can accommodate 1 to 6 players. In Burger Academy, players attempt to build specific cheeseburger combinations in as few moves as possible. Game setup is very simple. First, decide which level of difficulty you want to play. Shuffle the cards, place the deck face down. Line up the 4 plate boards, then create 3 stacks of randomly arranged burger parts. Each player selects a bid marker, and the game is ready to begin. To start a round, a card is revealed for everyone to see. Players then quickly place a bid on their marker based on the number of moves they think it will take to build that particular burger. Once everyone has placed a bid, they reveal their bids simultaneously. The player with the lowest bid gets a chance to build the burger. The player builds the burger by either moving parts from one pile to another, flipping parts on a single pile, or flipping parts while moving them to another pile. If the player succeeds in building the burger in the number of moves he bid, he earns a French fry point. If he fails to create the burger, all of the other players receive a French fry. Players continue to play additional rounds in the same way until someone reaches a total of 10 French fries. That player wins the game. When the weather is clear and comfortable, North Carolina has many great spots to explore. And the neat thing is you can often combine leisure with learning, especially if you're a student of history.
Let's take a drive to Wallace Simpson Whirligig Park in Wilson, North Carolina. Farm machinery repairman Wallace Simpson began making gigantic kinetic sculptures at his family farm in Wilson County when he was nearing retirement age. He kept making his whirligigs 7 days a week until about 6 months before he passed away at the age of 94 in May of 2013. By that time, though, visitors were making the trip to Wallace Farm to see his work. Without any advertising, it became one of Wilson County's top tourism destinations. His artwork began to be discovered by art collectors outside of eastern North Carolina. You can find his 55-foot tall and 45-foot wide Life, Liberty, and the Pursuit of Happiness whirligig at the American Art Museum in Baltimore, also a piece in the American Folk Art Museum in Manhattan. In 2010, as Simpson's health started to decline, a plan was created to make the Wallace Simpson Whirligig Park in historic downtown Wilson. The 2-acre park features 30 of Wallace Simpson's whirligigs. Right next to the Wilson Ballpark, it's an incredible place to walk around and appreciate the artwork of Wallace Simpson. I'm Storm Team 9 meteorologist Olivia Monteleone. See you next week for our next adventure.
The coast has always been tied closely to the military and economic history of North Carolina, and it's not just the ocean. Our state is well known for its variety of lakes and rivers, as meteorologist Christopher Tyndall explains.
As you look out over a pond or a swamp, you may find a yellow-bellied slider perched on a log basking in the sunshine. These turtles are native to eastern North Carolina, but have been introduced to areas in the Northeast and parts of Florida. Throughout its native range, yellow-bellied sliders are one of the most seen turtles. Due to their similar size and shape, they are sometimes mistaken for the red-eared slider. A key difference between the two is that red-eared sliders have a brownish-red stripe on each side of the head. Also, yellow-bellied sliders have a yellow stripe starting on their face and going down the neck. As with all reptiles, they are ectothermic, meaning they rely on the surrounding environment for body heat. As they sit on logs and banks soaking in the sunshine, they stay on high alert. Hence their name, they will slide into the water for safety if they sense danger. During late spring, females can sometimes be seen on land searching for a nesting spot. She will lay anywhere from 4 to 12 eggs at a time. Young turtles feed on insects and other small creatures, while adults mainly feed on plants. Because they rely on the environment for body heat, they have to play it smart when the weather turns cold. During the winter, yellow-bellied sliders will stay in the water surrounded by soft grass on the bottom. Some have even been known to take advantage of a muskrat's burrow. So the next time you're near a body of fresh water, keep an eye out. You may just see one of these turtles slide on by. In the studio, I'm meteorologist Christopher Tyndall, Storm Team 9.
So how much do you know about water? 8 questions, 2 minutes. Good luck. It's always fun to play a little trivia, but sometimes the weather can become quite serious in North Carolina.
Whenever hurricane season rolls around and you take a look at the season's outlook, you may hear terms like El Nino and La Nina. But what are they, and what does it do for us during hurricane season? By definition, El Nino and La Nina are warm and cool phases of a natural climate pattern across the tropical Pacific Ocean. This phenomenon as a whole is known as the El Nino Southern Oscillation. Naturally, the equator receives the most sunlight, therefore the water is warmer there. Well, under neutral conditions, prevailing airflow, known as the trade winds, push the warm water from the Americas towards Asia. Cooler water from deep down moves towards the surface to replace the wind-blown water. This is called upwelling. Upwelling brings an abundance of nutrients to the surface, which attracts a lot of bait fish and in turn game fish that commercial fishers catch. During an El Niño year, the trade winds weaken and the warmer water pushes back east towards the Americas. This leads to a decrease in upwelling, which also leads to less fish being caught. During a La Niña year, the trade winds are stronger than usual, pushing warm water towards Asia more so than usual. This leads to a dramatic increase in upwelling along the west coast of the Americas. The pattern shifts irregularly every 2 to 7 years. Although the shifts are irregular, the climate that it creates is very predictable. You may be wondering how something in the Pacific can affect our weather patterns here in eastern North Carolina. Well, you see, the El Niño Southern Oscillation really has a global effect due to the fact that it shifts the jet stream. Under El Niño conditions, the warmer water causes the jet stream to shift south of its usual position. This leads to drier and warmer conditions in the northern U.S. and Canada. However, the Gulf Coast states and Southeast are wetter than usual and experience more floods. Under La Niña conditions, the jet stream shifts north of its neutral position. This leads to drought in the southern United States and heavy rain and flooding in the Northwest and Canada. The position of the jet stream is critical when it comes to forecasting hurricanes. Tropical systems don't like wind shear, which is simply the change of wind speed and direction with height. However, the jet stream is full of wind shear. So during an El Niño year, the jet stream shifts south, disrupting tropical storm formation. But under La Niña conditions, the jet stream is further north, therefore little to no wind shear is present. This allows tropical systems to take shape, leading to a more active season. So the next time you look at a hurricane season outlook, you'll know what scientists are saying when they start talking about this important Pacific-based pattern.
We're always eager to introduce new generations to the wild world of weather, and we have the perfect way to do it. This is Josiah. Like many of our weather kids, he had a chance to enjoy some of the snowfall earlier this year.
I built a snowman and made snow angels.
But not all weather is fun, and Josiah knows that severe weather can be dangerous and a little scary.
The lightning of the thunderstorms because it makes a big boom sound.
Josiah really enjoys learning in school, especially mathematics, but his future career may take him down a different path.
A firefighter.
Josiah was ready to go to work on the green screen and helped us put a forecast together.
Rocky Mount got 36 degrees and Goldsboro got 37 degrees. Pink stuff is the mix. My name is Josiah and you want to learn more about the weather, go download Storm Team 9.
With Josiah's smooth presentation skills, you may be wondering how your child can become a Storm Team 9 weather kid. Just send me an email to jjackson@WNCT.com and I'll explain how everything works. For the Storm Team 9 Weather Kids, I'm Chief Meteorologist Jerry Jackson. Class dismissed. The weather itself is never dull, not here in North Carolina. So you should always make sure that you stay on top of it, and we'll do our part too.
As the weather heats up, so does your car. In this edition of Revving Up, let's take a look at how heat can affect your vehicle. One thing many people do in the summertime is sit in the car with the air conditioner running, even while idling. However, sitting still on a hot summer day can be detrimental to your engine. If it sits still for too long, then the engine can run hot, possibly scorching the bearings inside. Most car engines are liquid cooled and rely on the water pump to keep the coolant flowing through the engine and to the radiator. The radiator's job is to disperse the heat. However, if the radiator isn't catching wind from going down the road, then it's just sitting there, baking in the heat from the engine on top of the atmospheric temperature. While it's true the cooling fan can help move air through the radiator, it doesn't really matter if the surrounding air around the radiator is hot. Also, make sure you check the coolant level in your vehicle and make sure the belts are in good shape. Something else that can be affected by heat is your car's fuel economy. During the winter, people tend to start their cars a few minutes ahead of time so that the engine will reach operating temperature. However, in the summer, warm-up times are naturally reduced, so people don't need to start their car as early before taking off. This lack of idle time can increase your fuel mileage. Another way your fuel mileage will increase is by the fact that it takes less fuel to keep the car running in hot weather. Inside the combustion chamber, there is literally a small fire that occurs. That means if the air is already hot upon intake, then it will require less fuel to achieve this spark. On the other hand, colder air requires more fuel to generate a spark. On a side note here, more fuel means more power. This is why racers install cold air intake systems on their cars. The last and most important thing to remember is the fact that your car's interior can get super hot super fast. This is why you should never leave a child or a pet in the car unattended. Unfortunately, this can lead to heat stroke or even death. Remember, engines can be replaced, but lives cannot.
There are all kinds of games out there, many having themes closely associated with weather. Here's one in which wind plays a major role. Fire Tower is a board game published by Runaway Parade and Goliath Games. It plays 2 to 4 players, and a typical game lasts about 15 to 30 minutes. In this game, players must protect their personal fire tower from encroaching flames, balancing their water and resources even as the winds change direction. To begin, players roll the dice to determine the starting wind direction. Once the direction is determined, play begins. On each player's turn, they perform 2 actions. First, they place 1 fire gem adjacent to an existing flame, following the prevailing wind direction. Next, they can play a card from their hand or exchange for different cards. Now, the cards come in different types. Fire cards allow the player to spread the flames further along the board, preferably away from their tower. Water cards allow them to put out part of the fire. Wind cards allow them to change the direction of the wind, and fire break cards allow them to place protective barriers. As the fire continues to grow over alternating turns, eventually the flames will reach a player's fire tower. Players have a one-time emergency water bucket to attempt to save the tower, but if that fails and the fire reaches the top of the tower, it can't be saved, and that player loses. Play then continues among the remaining players until only 1 tower is left standing, and that player is declared the winner. Games are a good way to learn about science in a subtle way, but oftentimes kids prefer to get straight to the point.
Saturn's rings are the largest and most complex ring in our solar system. Spanning about 175,000 miles across, they are incredibly thin, only about 10 meters thick. They are composed primarily of billions of water ice chunks, ranging from microscopic dust specks to massive house-sized boulders. Saturn's rings make up an enormous, complex structure. From edge to edge, the ring system would not even fit in the distance between the Earth and the Moon. The 7 main rings are labeled in order in which they were discovered. From the planet outward, they are D, C, B, A, F, G, and E. The D ring is very faint and closest to Saturn. The main rings are A, B, and C. The outermost ring, easily seen with Earth-based telescopes, is the A ring. The Cassini division is the largest gap in the rings and separates B ring from A ring. Just outside of A ring is the narrow F ring, and beyond that are 2 much fainter rings named G and E. Saturn's diffuse E ring is the largest planetary ring in our solar system, extending from Mima's orbit to Titan's orbit, a little over 621,000 miles. The particles in Saturn's rings are composed primarily of water ice and range in size from microns to tens of meters. The rings show a tremendous amount of structure on all scales. Some of this structure is related to gravitational interactions with Saturn's many moons, but much of it remains unexplained. One moonlit Pan actually orbits inside the A ring in a 200-mile frame. The main rings A, B, and C are less than 100 meters thick in most places, compared to their radial extent of 38,600 miles. The main rings are much younger than the age of the solar system. They may have formed from the breakup of one of Saturn's moons or from a comet or meteor that was torn apart by Saturn's gravity.
The atmosphere has all kinds of visual wonders to behold, no matter the time of year, and few are more spectacular than the aurora borealis, as meteorologist Olivia Monteleone shows us.
Aurora
borealis, also known as the northern lights. Auroras are colorful, dynamic, and often visually delicate displays of an intricate dance of particles and magnetism between the sun and earth called space weather. When energetic particles from space collide with atoms and molecules in the atmosphere, they can cause the colorful glow that we call auroras. What causes auroras? The sun continuously produces an outflow of charged particles into the solar system known as the solar wind. When the solar wind reaches Earth, it can interact with Earth's magnetic shield, often depositing and accumulating energy there. When this energy is finally released, much of it rains down our atmosphere, causing aurora. Why are auroras colorful? An aurora can appear in a variety of colors, from an eerie green to blue and purple to pink and red. When particles from space bombard gases in the atmosphere, they can give the atoms and molecules of the gases extra energy that's released as tiny specks of light. The color of an aurora depends on the type of gas that it hits and where that gas is located in the atmosphere. Oxygen excited to different energy levels can produce green and red colors. Green occurs roughly between 60 to 120 miles altitude, and red occurs above 120 miles. Depending on the type and the energy of the particle is interacting with, nitrogen can give off both pink and blue light. Sometimes the light emitted by these gases can appear to mix, making the aurora seem purple, pink, or even white. They typically occur between 60 degrees and 75 degrees of latitude, and this is called the auroral zone. By using ground-based scientific equipment, we can learn a lot about auroras. With tools like magnetometers that show changes in Earth's magnetic field and radar networks that monitor particles' activity in the upper atmosphere, scientists can analyze the various effects that occur during auroral displays.
Well, that just about does it for this week's edition of Weather or Not. As you probably learned by now, you never know what you're going to see on this show or who you're going to meet. We try to keep it fresh for you every week with new episodes and new content. And remember, we change with the seasons too. I can't wait to show you what we have lined up later this year for Christmas and even beyond into spring. So make sure you catch a new episode whenever it drops. And remember, our goal is to keep you informed, enlightened, and hopefully a little happier. I'm Storm Team 9 Chief Meteorologist Jerry Jackson. Thank you for joining us for Weather or Not.